In this video, we're going to learn how to factor using difference of squares. Now, before we get into how to factor, let's first talk about how to recognize whether something is a difference of squares problem. And difference of squares problems have very key distinguishing features. The first one is they'll only have two terms in them. So in this case, we have 4x squared, that's our first term, and our second term is 9y squared. So we have two terms. Both of those terms have to be perfect squares. So remember, when you're looking at your numbers, perfect squares would be 4, 9, 16, 25, 36. So any number squared would be a perfect square. And your variables have to have even exponents in order for this to work. The last feature of a difference of squared problem is this negative sign in between. And that's why it's called difference of squares. You have to be subtracting your two terms. So now that we've recognized that this is in fact a difference of squares problem, how do we factor it? The first thing we're going to do is we're going to take the square root of both of these terms. So I'm going to take the square root of 4x squared. The square root of 4 is 2. The square root of x squared is x. And I'm also going to take the square root of 9y squared. And here, the square root of 9 is 3. The square root of y squared is y. So I've square rooted both of these terms. Now I'm going to set up two brackets. And each bracket is going to start with the square root of first term. So they're both going to start with 2x. And they're going to end with the square root of the second term, which are 3y. So I'm going to end these brackets with 3y. And then one of these brackets is going to get a positive sign, one is going to get a negative sign. And that is how you factor them. So the answer to this question is 2x plus 3y times 2x minus 3y. Let's look at another question. So pause the video and try this out, and then we can solve it together. All right, so because I have a decimal here, I'm actually going to start by factoring out that decimal. So when I factor it out, I get 0.16 times t squared minus, so 16 divided by 0.16 is 100. So now we're working with t squared minus 100 s squared. I'm going to go ahead and take the square roots of both of those terms. So the square root of t squared gives me t, and the square root of 100 s squared will give me 10s. I'm then going to write out my two brackets, so 0.16, and remember the brackets start with the first term, so t plus and end with the last term, 10s, and t minus 10s. And that would be your answer. On to the next problem. Let's look at what we have next. We have this question right here. So again, pause the video and give it a try, and then we'll solve it together. So when you try to solve this problem, originally you might be looking at it and thinking 50 and 72 are not perfect squares. So this can't be a perfect squared problem. However, 50 and 72 are both divisible by 2. So when we take the 2 out by factoring out the 2, we get left with 25x squared minus 36. And both 25 and 36 are perfect squares, so now this is a difference of squares problem. So sometimes you'll need to common factor first. And then what we're going to do is take the square root of both terms. So we have the square root of 25x squared, which is 5x, as well as the square root of 36, which gives us 6. And then we can plug those numbers in to our two brackets. So the first bracket will be 5x plus 6, and the second bracket will be 5x minus 6. Let's try one more example. So our last example is x to the power 4 minus 1. They're both perfect squares. We have an even exponent, which means you can square root that. So we're going to square root each term. The square root of x to the 4 will give us x squared, and the square root of 1 gives us 1. So writing out our next line here, we have x squared plus 1 times x squared minus 1. Now the trick with this question is you can think you're done, but x squared minus 1 is still a difference of squares problem. We have a perfect square minus another perfect square. So what we've done here is we've created a second difference of squares, and we have to factor that in order for this question to be factored fully. So now we're going to take the square root of x squared, which is going to give us x, and the square root of 1, which is going to give us 1. So in our next line, the x squared plus 1 stays exactly the same. We can't factor that further, but the x squared minus 1 will change into x plus 1 times x minus 1. And now that is fully factored.